Now, after looking out the paging technique, let's see what is there in the page table entry. So we know that the page table will look like this. So we have what page number on it and the frame number. So that what we have learned till now, right? So we have the page like this. Here we have the frame number or the frame, and here we have the page number. So this is 10123, and let's say this is 4 5. In that way it will go on. So this will contain the frame. Let's say this is frame number 1, this is frame number 6, this is frame number 8, this is frame number 10, this is frame number 3, in that way. So this what we know about the page table till now, right? But there are many other entry other than frame number. Okay, so we have some more entries are there other than the frame number in the page table, and these entries are written here. So we have some 5 more entries. The first entry is called present and absent entry. Then we have the protection, reference, caching, and dirty. Let's see one by one all these entry, and then we will get to know that all those page table entry. Now it is saying that all these from here to here means frame number is mandatory, but from here to here, all these 5 different entries are optional information. So maybe some of the entries we can find in the table, maybe 2 entry we can find in the table, maybe these 3 entry we can find in the table, maybe these three will find in the table, maybe these three will find in the table. So it doesn't matter that what are the entry that we are finding, because it is optional. It's not like all always we'll have all those entries, right? Now let's talk about the frame number. So we know what is frame number is. It gives the frame number in which the current page you are looking for is present. The number of bit required depend upon the number of frames. Frame bit is also known as the address translation bit. So it is called address translation bit, and this frame number is in the form of bits, right? Like this. We'll put like this. So this is the number that we are putting, and these how many bits are required depend upon how many frames are there. So if I assume that we have only 8 number of frames, so how many bits will be required? So we required 3 bits, right? So let's say I'm looking for frame number 2 here, so it will be like this. If I look for frame number 3 here, so it will be like this. If I look for frame number 7 here, it will be like this. If I look for frame number 0 here, it will be like this. So these type of entry you can find it here in the frame number, right? Next is the present and absent bit. So what is present and absent bit? It will be, if it will be 0, this bit will be represented with 1 bit. If it will be 0, it means that that particular frame number is not at all present, or in the frame number that page is not present. And if it is 1, then I can say that it is present. So what it is saying, that present or absent bit says that the particular page you are looking for, it is present or absent. So in this particular frame, my page is page number which we are looking for, it is present or not. So 0 will tell me it is not present, 1 will tell me it is present. Sometime it is called valid or invalid bit, right? So sometime it is called valid or invalid. This is another name of present and absent. Protection bit. What is a protection bit? So protection bit says that what kind of protection you want on the page. So these bit is the protection bit. Protection of the page frame, read, write, etc. So we have 3 bits here generally. So read, write, and execute in that way. So we'll put it like this. If we have the permission on only read, so it will be like this. If we have permission of only write, it will be like this. If we have the permission of read and write, it will be like this. If we have the permission of read, write, and execute, it will be like this. So it will be of 3 bits. Then there is a reference bit. Reference bit will say whether this page has been referenced in the last clock cycle or not. It is set to 1 by hardware when the page is accessed. So whenever the page is accessed, the reference bit will be 1. Otherwise, it will be 0. Means if the page was not accessed recently, it will be 0. If the page is accessed recently, it will be 1. Okay. Now let's go to the other two. The first one, the next one is the caching. What is caching? Caching enable or disable. So sometime we need to fresh the data, right? Let us say that the user is typing some information in the keyboard, and your program should run according to the input given by the user. In that case, the information will come into the main memory. Therefore, main memory contains the latest information which is typed by the user. Now, if you try to put that page in the cache, and the cache will show the old information. So whenever fresh is required, we didn't want to go for the caching or many levels of memory. The information present in the closest level of the CPU and the information present in the closest level of the user might be different. So we want the information has to be consistent, which means whether the information user has given, the CPU should be able to see it at first as possible. Uh, that is the reason we want to disable caching. So this bit enable or disable caching in the page. So what it is saying that whenever we do the modification, so modification will be done in the caching and it will be reflected into the uh, main memory. But if it is not reflecting, means whatever value you are getting is the old value. So for that we have 2-bit enable and disable. It will be either 0 or it will be either 1. If it will be 0 means it is disabled, caching is disabled. If it is 1, it means that caching is enabled. Next one is a modified bit. What is modified bit? Modified bit says that the whether page has been modified or not. Modified means something you might try to write something on the page. If the page is modified, then whenever you should replace that page with some other page, then the modified information should be kept in the hard drive. So, or it has to be written back. It has to be saved back. It is set to 1 by hardware on write access to page, which is used to avoid return when swapping out. Sometimes this modified bit is also called dirty bit. So this is the modified bit. It is also called modified and is all called dirty. So we have 0 or 1. Okay. So what happened? Let's say we have putted the page into the frame. Now we will do some modifications on the page itself. So what will happen is this dirty bit, we have to make it a 1. Why? Because we have done some modification. And why we are doing that? Because there is a concept of swap in and swap out. Okay. So let's say we are having this main memory and we are having this big secondary memory. So when we take the program from secondary memory to main memory, this is called swap in. And when we are taking the data from main memory to secondary memory, that is called swap out. Okay. So when we are doing swap in, it means that whatever program we have here, we are putting here, right? And we have to swap out. When we have to swap out, if the dirty bit is 1, otherwise we doesn't have to swap out. Are you getting it? Because we already have this space, so why to overwrite on that? So we doesn't have to overwrite again on that. If the modification has been done here, then only we'll have to modify, we'll have to swap out. Otherwise we doesn't have to swap out. We just have to remove the page from here. Okay. That is how we need this particular dirty bit or modified bit. So modified bit is 1, means this page is modified here in the main memory. And when we are removing that page from the main memory and we are doing a swap out, it means we are giving back the data to the hardware, to the hard disk. So we have to write it again. Otherwise, we doesn't have to write it if it is 0. Getting it? This is a very good, you can say, additional information that is applied here. So this is all about page table entries. So how many entries are there? We have total 6 entry. 5 entries are information or the optional entry, and 1 entry should be mandatory, which is the frame number.